Hello friends, and welcome to Sleepy Brain Science Channel. Close your eyes for a moment and imagine a world completely silent. No hum in the garden, no flutter near the flowers, no golden jars on the kitchen shelf. A world without bees. Difficult to picture, isn't it? Bees have been on this planet for over 120 million years. Long before humans walked the earth, long before the first forests stretched toward the sky, bees were already doing what they do best, moving quietly from bloom to bloom, carrying with them something invisible and absolutely essential. They began as wasps, distant ancient relatives who once hunted insects for food. Then, slowly, over millions of years, something shifted. Instead of chasing prey, they began to chase pollen. They became gentler. They became gatherers, and in doing so, they became one of the most important creatures this planet has ever known. Tonight, we are going to drift into their world, not rush through it, just float, like a warm afternoon, like the slow drip of honey. Let the story carry you. The bees are ready, and so are you. Somewhere in a hollow tree, or tucked beneath the eave of an old wooden barn, a hive begins. It does not start with 1,000 bees or 10,000. It starts with one, a queen, alone, newly born into the world with nothing but her instincts and an ancient memory written into her very cells. She finds her spot. She begins to build. The wax she uses does not come from outside. It comes from her own body, secreted from tiny glands on her abdomen, pale and almost translucent at first, softened by her legs, shaped by her jaw into the first perfect hexagon. And here is something worth resting with, the hexagon. Every honeybee on Earth builds in hexagons, not because they were taught, not because they copied, but because geometry, it seems, is built into them. The six-sided shape uses the least amount of wax to create the most space. It is, in every sense, perfect. The hive grows slowly, first a few cells, then a few more, and soon the queen is no longer alone. Her daughters arrive, workers, thousands of them, each one knowing exactly what to do. The hive breathes, it hums, it becomes alive. She is larger than the others, longer, slower moving, and yet the entire hive exists because of her. The queen bee does not give orders. There are no commands passed down from above. The hive has no hierarchy in the way we might imagine, and yet everything works seamlessly, beautifully, because of the chemicals she releases. Called pheromones, these invisible signals drift through the hive like a soft perfume. They tell the workers she is alive and well. They shape the behavior of every bee around her. They keep the colony calm, focused, unified. A queen bee can live for up to 5 years. In that time, she may lay as many as 2,000 eggs in a single day, not by choosing, not by deciding, but by responding to the needs of the hive as it grows and shifts around her. She never leaves the hive except once on her mating flight. High above the earth, she will meet with dozens of drones, storing their contribution within her body, enough to fertilize eggs for the rest of her long life. Then she returns. She descends into the warmth and hum of her home. She settles on the comb, and the hive continues, breathing, humming, living. If the queen is the heart of the hive, the worker bees are everything else: the lungs, the hands, the memory, the warmth. Worker bees are all female. They are smaller than the queen, and they will never lay eggs of their own. Their lives are short, just 6 weeks during the busy summer months, but in those 6 weeks they will work every single day. A worker begins her life inside the hive, cleaning the cells from which she just emerged. Then she becomes a nurse, feeding the larvae. Then a builder, adding wax to the growing comb. Then a guard at the entrance, checking each returning bee for the scent of the hive. And finally, she becomes a forager. She steps out into the world for the first time. She will fly up to 5 miles from the hive in search of flowers. She will visit up to 1,000 flowers in a single trip. She will carry pollen packed into the small baskets on her legs and nectar stored inside her body. She will return, she will dance, she will go again. In her entire lifetime, a single worker bee will produce just 1/12 of a teaspoon of honey. 1/12 of 1 teaspoon. Think about that the next time you slowly stir a warm cup of tea. Imagine needing to give someone directions, but without words, without a map, without pointing, using only your body in the dark on a surface that vibrates beneath you. This is what bees do every single day. When a forager finds a particularly good patch of flowers, she returns to the hive with more than just pollen. She carries information, and she shares it through one of the most remarkable forms of communication in the natural world. She dances. The waggle dance, it is called, a figure-8 pattern performed on the vertical face of the honeycomb. The angle of the dance tells other bees the direction of the flowers relative to the sun. The length of the central waggle run tells them the distance. The energy she puts into the dance tells them how good the flowers are. Other bees crowd around her. They touch her with their antennae. They feel the vibrations through the comb. And when she stops, they know exactly where to go. Miles away, to a field of clover or a hillside of wildflowers, they will find it. Carl von Frisch spent decades studying this dance. In 1973, he won the Nobel Prize for decoding it. Nature had been speaking all along. We simply needed to learn to listen. Of all the things a bee produces, none is more familiar to us than honey. That warm, golden, impossibly sweet substance that has been found in ancient tombs, still perfectly preserved after 3,000 years. Honey does not begin as honey. It begins as nectar, a thin, watery liquid inside a flower, mostly sugar and water, produced by the plant to attract pollinators. A forager drinks the nectar through her long tongue, storing it in a special chamber called the honey stomach, separate from her actual stomach, used only for carrying. On the flight home, enzymes in her body begin transforming the nectar. Back at the hive, she passes it mouth to another bee. That bee passes it to another. Each exchange adds more enzymes, breaks down more sugars. Eventually, it is deposited into a cell. Then the bees fan it, hundreds of wings beating together, driving out the moisture until the water content drops below 18%. At that point, it will not ferment, it will not spoil. It becomes honey. The hive caps the cell with a thin layer of wax. The work is done. What began as a flower's whisper has become something that can outlast civilizations, something sweet enough to carry through centuries, untouched, unchanged. Long after the honey is gone, the wax remains, and it tells a story all its own. Beeswax is produced by young worker bees between 12 and 17 days old. 8 special glands on their abdomen secrete tiny flakes of wax, white and translucent, no larger than a pinhead. To produce 1 pound of wax, bees must consume roughly 8 pounds of honey. The cells they build are not just storage units, they are a masterpiece of structural engineering. Each hexagonal cell is tilted at precisely 13 degrees from horizontal, just enough to keep liquid honey from sliding out. The walls are a fraction of a millimeter thick, yet they can support 30 times their own weight. The cells are used for everything: storing honey, storing pollen, housing larvae, incubating eggs. Different sizes for different purposes: smaller cells for worker bees, larger cells for drones, special elongated cells for new queens. Every measurement is precise, not because a bee measured it, but because the measurement is the bee. For centuries, humans have used beeswax for candles, cosmetics, wood polish, and medicine. Ancient Egyptians used it to seal mummies. Sailors used it to waterproof rope. Artists used it to preserve paintings. We borrowed the architecture of the hive and carried it into our own world. We still do. We think of bees and we think of honey, but honey is only half the story. Pollen is the other harvest, and in many ways it is the more important one. Pollen is protein. It is the food that bees feed to their larvae. A colony needs pollen to grow, to thrive, to raise the next generation. Without it, the hive weakens. Without it, bee populations collapse. When a forager lands on a flower, she doesn't simply collect pollen. She bathes in it. She rolls around on the stamens, packing the fine yellow dust into the stiff hairs that cover her body. She combs it from her fur with her legs, packs it into the small, concave baskets called corcibulae on her hind legs. Sometimes the pollen load is so heavy it almost looks like she's wearing tiny yellow boots. Different flowers produce different pollen, different colors, different sizes, different nutritional profiles. Bees somehow know which pollen their hive needs most. They communicate that too, through their dances, through chemical signals, through the changing proportions of what comes through the hive entrance each day. And while all this is happening, while the bee is focused entirely on her task, something extraordinary takes place. Pollen dusted onto her body brushes against the next flower she visits. A transfer occurs. Fertilization begins. A fruit forms. A seed is made. A tree will grow. And the bee flies on, not thinking of anything. Here is a truth so large that it is almost impossible to hold. 1 in every 3 bites of food you eat exists because a bee visited a flower. Almonds, apples, blueberries, cherries, cucumbers, avocados, coffee, none of these exist in abundance without bees. The list is long, longer than most people realize. Pollination is not something bees do for us. They do it for themselves, seeking food, following scent, chasing the warmth of the sun. The gift to us is a byproduct, a side effect of a bee simply being a bee. The relationship between bees and flowers is one of the oldest partnerships on Earth. Flowers evolved color, fragrance, and nectar specifically to attract pollinators. Bees evolved long tongues, pollen baskets, and an exquisite sensitivity to scent specifically to harvest from flowers. They shaped each other across millions of years, grew toward each other, became necessary to each other. Some flowers are so specialized they can only be pollinated by a single species of bee. If that species disappears, the flower cannot reproduce. If the flower disappears, the bee has no food. This is what ecologists mean when they speak of fragile systems. A thread pulled in one place unravels the whole cloth. The bee is not just a pollinator. She is a keystone, a small, winged, humming foundation upon which much of our food, much of our wild world quietly rests.
In every hive there are males. They are called drones. They do not sting, they do not forage, they do not build, they do not clean. They eat the honey that others have made. They live inside the hive, waiting. They are waiting for one thing, the chance to mate with a virgin queen. Drones emerge from unfertilized eggs, a quirk of bee biology called parthenogenesis. They have a mother but no father. They have grandfather but no grandmother on one side. Their genetics form one of the stranger family trees in the natural world. When a new queen is ready to mate her flight, drones from many hives will gather high in the air, sometimes hundreds of them, in what are called drone congregation areas. The same spots year after year, generation after generation. Nobody knows how they find these places. The queen flies up. The fastest drones reach her. Mating occurs in seconds, high above the earth. For the successful drone, it is also the end. The mating process is fatal. He falls away. He is gone. As autumn comes and flowers fade, the workers stop feeding the remaining drones. They are nudged toward the entrance. Eventually, they are pushed out entirely. The hive grows smaller. The hive grows quieter. The hive prepares for winter. And the drones, briefly enormously important, are gone. When the cold comes, the bees do not leave. There is no migration, no hibernation, no stillness. Inside the hive, the colony does something remarkable. It clusters. Tens of thousands of bees press together into a dense ball around the queen at the center of the comb. The outermost bees face inward, forming an insulating shell. Those closest to the center vibrate their flight muscles rapidly, not flying, just shivering, generating heat. The cluster temperature at the center holds steady at around 90 degrees Fahrenheit, even when the air outside drops far below freezing. As winter deepens and the cluster needs more warmth, the outer bees move to the center. Those who have warmed themselves move to the outside. A slow, constant rotation, a living, breathing heat machine. They eat their stores of honey, slowly, carefully. They have spent all autumn preparing for this, building up enough reserves to survive until the first flowers return in spring. A well-prepared hive with a good queen and enough honey will make it through the darkest months. the colony will emerge smaller than it entered, but alive. And when the first warm days come and the first flowers open, the queen begins to lay, the workers begin to forage, the hive begins to grow again. Winter was not an ending, it was just a long, slow breath. For all their resilience, bees are fragile in ways that matter. In recent decades, something has been going wrong. Colony collapse disorder, it was called. Whole hives emptying almost overnight. The workers simply vanishing, leaving behind the queen, the honey, the brood, and silence. Scientists searched for a single cause and found something more complicated, many causes layered together. Pesticides, particularly a class called neonicotinoids, disrupt a bee's ability to navigate, to learn, to find her way home. A forager sprayed with even a tiny dose may not make it back to the hive. Habitat loss means fewer wildflowers, fewer diverse sources of pollen. A bee eating only one type of pollen is like a person eating nothing but white bread. A parasitic mite called Varroa destructor has spread to nearly every corner of the world, weakening bees and spreading viruses. Climate change is shifting the timing of flowers, blooming earlier or later than bees expect, creating a mismatch that leaves both the flower and the bee without what they need. None of these things alone would be enough to threaten the bees. Together, they create a pressure that some colonies simply cannot survive. And yet, bees persist, they adapt, they endure. Because 120 million years of existence is not easily undone.
Here is something gentle to carry with you as you drift towards sleep. The bees do not need saving by governments or corporations alone. They need saving by gardens, by window boxes, by a patch of clover left to grow in the corner of a lawn. Planting flowers, even just a few, creates pathways for bees through neighborhoods that might otherwise be all pavement and glass. Native flowers are best because bees have evolved alongside them, know their scent, know their timing. Leaving a shallow dish of water outside gives foraging bees something to drink on hot days. They tire easily. They thirst just like anything living. Buying honey from local beekeepers supports people who tend hives in ways that keep them healthy, not mass-produced, not shipped from across the world. Local honey from someone who watches the hive, who knows the queen, who understands the work of each small bee. And simply being calm around bees. A bee landing on your hand is almost always just resting or curious about a scent. She does not want to sting. Stinging costs her everything. It is fatal. She will only sting if she believes the hive or her own life is at risk. Breathe. Hold still. Let her discover that you are not a threat. She will fly away, back to the hive, back to the comb, back to her small, enormous life. Somewhere right now, a beekeeper is lifting a frame from a hive, wearing a veil, moving slowly, speaking softly, watching. Beekeeping is one of the oldest human practices. Evidence of it stretches back 9,000 years. Cave paintings in Spain showing figures gathering honeycomb from wild hives. Ancient Egypt kept bees in clay cylinders along the banks of the Nile. Greek philosophers wrote about hive behavior with wonder and precision. The relationship between beekeeper and hive is unlike any other form of animal keeping. The bees are never tamed. They are never truly domesticated. They continue to live as they always have, following their instincts, their chemistry, their ancient rhythms. The beekeeper simply creates conditions, offers space, observes. A good beekeeper can read a hive the way a skilled reader reads a page. The sound of the hive, a steady hum, or something more agitated. The movement at the entrance, foragers returning steadily, or something irregular. The smell, warm, sweet, full of life, or something off. They learn the queen's presence without seeing her, by the calm of the workers around her. They learn the health of the colony by its weight, its sound, its smell. The beekeeper does not command the hive, the beekeeper listens to it. And in that listening, something quiet and essential passes between human and bee. The sun is low now. The flowers have closed. The last foragers have returned. At the entrance of the hive, a few bees stand fanning their wings, drawing fresh air inward, pushing warm air out. The hive breathes. Inside, the queen is at rest. The workers have slowed their movement in the cooling evening air. The comb glows faintly in the dark, full of honey, full of life, full of the patient, invisible work of 10,000 small lives. Bees do not know that they are remarkable. They do not know that scientists have spent lifetimes studying their dances. They do not know that their wax has sealed the tombs of pharaohs, that their honey has survived 3,000 years unaltered. They do not know that a third of what we eat depends on their wings. They simply do what they have always done. They wake with the light. They move toward the flowers. They carry and build and tend and return. They hum. That hum is one of the oldest sounds on Earth, 120 million years old. It was here before us. In a very real sense, it made the world we eat from, the world we live in, the world we love. So tonight, as you drift to sleep, listen for it somewhere in the back of your mind. Not urgent, not loud, just steady, just warm, just real. The quiet hum of a world that works because small things do their work faithfully every day without asking for anything in return. Sleep well. The bees are still out there, and in the morning, the flowers will open again.